Hello, Dave Kenworthy here, 14th of the 11th, 2022. And what are we looking at today? It's going to be the meter in the design of the Giza Pyramid. And I've made contact with Bob Crielly. And Bob has put a paper up on academia, and I'm looking at a bit of it now. It's got a video with it. And it says the height of the Great Pyramid is 146.6 meters. And there's also a template that he's put up, the 711 template. And I agree 100% with this. And he's calling it the Hemiunu template, and it was discovered by myself and Larry Pahl. Now, I'm in contact with Larry as well. And it's interesting that they've actually discovered this between them. And I want to look at the meter now in the design, because reading this paper by Bob, it triggered me to actually look at the relationship between this meter in the height and the meter in the base that Glenn Dash suggested. And Glenn Dash suggested this number of meters in the base, 921.6, and Larry and Bob are suggesting 146.666 in the height. Or when we do put that number in the height, we get 2 pi built into the design of Giza as that, giving this number here 3.141818. And that number is used in historical metrology by Algernon Berriman and by other metrologists as well. And we're going to look at what effect that has on the Giza design now. And the first question is, was the meter used in historical metrology? Yes, by Berriman. He gives 39.366, 39.375 and 39.6 inches as an ancient meter. Was the French meter used in historical metrology? Open for debate. Now I'm going to go onto a website where we can actually look at what these meters give us when we dig down into what they're comprised of in prime numbers. So let's open up this Numbermatics website and we'll look at the French meter, 39.37, only we won't put the decimal point in because this doesn't take decimal points. So we'll just do a search on 3937 and see what that number gives us. It's an odd composite number composed of 2 prime numbers multiplied together. Now we'd be hoping here for 11 and 7, but we're not going to get it. We're getting 31 and 127. So, as a metrologist, I would say that that's a cack-handed pair of numbers there. I'm not happy that they were being used by the ancient designers at all. So let's put 39.375 in. See what happens. An odd composite number composed of 3 prime numbers multiplied together. Now, and what we're going to get? 3 squared times 5 to the power 4 times 7. And there's the 7 of the 711. So that is exactly what we're expecting. Low prime numbers, and the numbers are being squared and taken to the power 4. So that's very good for 39.375. Let's have a look at 39.366, which is Berriman's first meter. An even composite number composed of 2 prime numbers multiplied together. Tasty. Oof, look at that beauty. 2 times 3 to the power 9. I would say a big yes there to Algernon Berriman for discovering that number. I wish I knew how he'd done it, because, you know, it would answer a lot of questions, but the man is an absolute genius. I'm lucky to have his book. So now we're going on to 39.6. What's that giving us? 396. 3 prime numbers again. I'll bet 11's turning up here. Oh, 2 squared times 3 squared times 11. Exactly what Bob would be expecting. He's writing his paper about 11 and 7. And there you go, Bob. That's why those meters were being used. And probably why the modern French meter, let's go back to it. It's pretty yucky, isn't it? I mean, it's a good number, don't get me wrong. The French did brilliantly to calculate that as the meter to give the polar circumference. It's a fantastic piece of work. But it's not working in historical metrology, even though we think it does. So what we've got to do now is look at why. Why is it working when it shouldn't be? So let me get my spreadsheet back up. So we go 39.37, we've got 921 in the base and 146.66 in the height. We're getting 36283, 392 in the base and 5774266 recurring. And I've talked about that number, 266 recurring in the base. And it's giving this version of pi here, which is fantastic. And Petrie's height is 5776 and we're getting 5774266. Unbelievable. But we're getting numbers that are a bit unexpected. You know, that's near to what Dash is telling us they were getting. But we know for definite that when we use this 39.375, we multiply that by 921.6, we get 36288. Jaw-dropping result. And what's the height? 5775, another jaw-dropping result. Because we know when we use that with pi as 22/7, we get 363, 12 inches more there. So obviously, these versions of pi were being worked by the ancients. And why were they? Let's just do the final version, 39.6. It's giving 36495.36. John Neal, both these numbers, Jim Wakefield, and myself, we go by these numbers. John Neal goes by these. Now, when we want to get the Giza base from that, we use pi as 44/7 in the design of the Giza pyramid. We get this and this. That's what me and Jim go with, and this is what John Neal and Harry Sivertsen go with. There's no difference. The only difference in the metrology is the version of pi that's being used. So we're both right. But what I'm saying is 36666.667 is the intentional base length. Now, it might not have been stated in inches, it might have been in other units, but certainly that is the base 100 unit, and that's the top of the scale. And you can make it any number you want to. But when we use inches, that is what they were aspiring towards, and that's 366.666 solar days. And this version is astronomical. And we've got to ask the question, why is it astronomical? So let's have a look at this. These two versions of pi first. I've written a paper about this. They were using 22/7, and we know this because of the work of Milo Gardner. And we've got to accept that they were definitely using 22/7 because Milo has tracked it to the ancient papyri, the Egyptian papyri. And we know this other version that's been coming out here is 22/7 times 3024 divided by 3025. And that's why these two different versions are coming out. When we use 3024, we get that, and when we use 3025, we get that. And that's all there is to it. That's 22/7 times 3024 divided by 3025. So that's that. So now we've got this astronomical question. We want to answer it, and the man for the job is a metrologist called Jim Wakefield, and he is a brilliant metrologist. I hope he doesn't mind me saying that, because it's fairly modest as well. But he's a high quality metrologist, and Jim is saying 4 Indus feet times 16 digits equals 64 digits. 64 digits divided by 25 is 2.56 royal cubits of 20.625 inches. He doesn't tell you why, but it's 52.8 inches. And then he says tons of stuff. Try 756 feet divided by 25.6, giving 29.53125 synodic months times 12 equals 354.375 lunar year. This is in the Giza design. And Jim's found it. The question is, why is it in the Giza design? And why has Jim found it? And why is he finding all these other numbers like 345.6 in the Giza design? Why is it happening? And the reason is, and we know this from the work of Dennis Payne now, he's putting up so many papers on academia that are proving that the Egyptians knew this lunation period of 29.53 days. And there's no doubt about it. But they'd also smoothed it down to 29.33 days. And what we can say is that the meter was being used because it was a lunar standard. It produced lunar measure when it was interpreted. And the way to interpret the meter, which is here, we can put in the French. I've put 10 French meters there, so it's 393.7. So we put that in, and we get this value here, 35433.